Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on February 2nd, 2026, just 2 days ago. It introduces a method that leverages real-world software evolution histories to train agents, achieving a 47% gain on the two-lathlon benchmark using only 239 training samples. The paper is titled, daVinci-Agency, Unlocking Long-Horizon Agency Data Efficiently. And as we'll see later, the way it uses pull request chains to teach long-term planning is really quite clever. And for those interested in the implementation, the authors have shared their code on GitHub. On Hugging Face, the 353 billion parameter daVinci-Agency weights are available to download and try with Python examples for complex software engineering and long-horizon planning. Figure 1 illustrates the core idea, unlocking long-horizon agency through chains of pull requests. On the left, we see how the method mimics real software development. Instead of treating tasks in isolation, it follows a sequence where an issue leads to a pull request, code is merged, and subsequent feedback triggers new refinements. This creates a natural chain of decomposition and consistency. The chart on the right highlights the dramatic efficiency of this approach. Compared to baselines like SWE Smith or Code Agent Dataset, daVinci-Agency, marked by the blue star, achieves a 148% improvement while using only 0.3% of the training samples, proving that structured supervision beats raw data volume. Figure 2 helps us understand exactly where this method fits by comparing 3 levels of software engineering scope. On the left, the function level represents simple, isolated tasks like code completion, which typically require just a single tool call. In the middle, the feature level steps up complexity, asking the agent to navigate a repository and implement a single feature, often taking around 40 steps. But on the right is the project evolution level, which is the focus here. This requires sustaining a project through multiple versions, planning, generating patches, and fixing subsequent bugs, spanning over 100 tool calls per trajectory. So Figure 3 breaks down the characteristics of the dataset generated by this pipeline. The sunburst chart on the left highlights the domain coverage, which spans both code maintenance and functional evolution to ensure diverse engineering skills. Then, the histograms on the right reveal the sheer scale of these interactions. The top graph shows an average context length of nearly 85,000 tokens, while the bottom chart indicates that agents typically engage in over 100 tool use turns per task, confirming the high complexity of these long-horizon scenarios. Figure 4 details the complete data synthesis pipeline. On the left, Step 1 begins by mining GitHub to construct query chains, specifically targeting dependencies where one pull request builds upon another to form a topological sequence. In the top right, Step 2 executes the rollout data collection. Here, the agent receives a query and base commit, interacts with the environment to generate a patch, and is immediately verified against the ground truth code. Finally, Step 3 in the bottom right illustrates the training data processor, which applies rejection sampling to filter out incorrect trajectories, ensuring that only high-quality, verifiable solutions make it into the final dataset. With the data generation complete, Table 1 now presents the main performance comparison using the GLM 4.6 model. The middle rows list baselines like SWE Smith and Code Agent, which train on nearly 66,000 samples yet often struggle to generalize. In contrast, the bottom row highlights the proposed daVinci-Agency model. Despite using only 239 training samples, it outperforms those massive baselines across the board, achieving the highest average score of 0.475. This confirms that learning from structured, evolutionary chains is far more effective than simply scaling up unconnected data points. Well, Table 2 broadens the scope, testing whether this fine-tuning recipe generalizes across different model families and sizes. The top section lists strong baselines like DeepSeek v3.2 and Kimi K2 thinking. The lower sections show pairwise comparisons, where base models are fine-tuned with daVinci-Agency. Across the board, we see consistent gains. Most notably, the fine-tuned GLM 4.6 model at the bottom reaches a top average score of 0.475, significantly outperforming even the massive 235 billion parameter QN model. Wrapping up, 2 takeaways stand out. Logical dependency beats data volume, and context is king. By training on just 239 pull request chains, daVinci-Agency outperformed baselines using 60,000 samples. This confirms that mastering long-horizon tasks requires seeing the full evolution of a project, not just isolated snapshots. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.